Hi there, my name's Glenn and I'm preparing a series of educational videos that are all about Arduino. In this video I want to look at the importance of blink without delay. It's quite a simple program, a lot of people tend to skip over it, but it actually teaches a very important fundamental concept for Arduino programming. And it basically allows you to do, or give the appearance of doing many things at once. So that could be reading sensors, updating displays, and also responding to user input. So in this program I'll look at what the problem is, how you can sort of get lag and delays in dealing with user input, and then how to deal with that, which is the blink without delay. But just before we get started, I'd like to hear from you, so please leave a comment if this has been helpful. Also check the like and subscribe and notify so you'll hear about new posts when I publish them. And also you can find me on Patreon, so have a look over there, and if you can help sponsor me, that would be wonderful. Okay, so with that, let's get started and find out all about Arduino. Okay, so this is the circuit we'll use for this testing of the blinking of the LEDs and the state machines. As you can see, I've got 3 LEDs with current limited resistors and a push button. I'll just bring up the circuit. And so there we have it, the 3 LEDs. They're connected to pins 11 and 10, that's these two. And then this one, which will sort of link to the button in the code, is connected to pin number 3. And then of course the button. Now normally you would have a pull-up resistor from here to here. Well, normally you can. It's a good idea to do so. But in this case we'll use a pull-up resistor that's internal to the Arduino. And I'll show you how that works in the code when we get to that part. This video is going to be in 2 parts. We'll start with what the problem is, and then we'll look at what the solution is. So start by loading up the program. So we'll launch the IDE. And so what we'll do is load up the problem. The problem is blink. So we'll start with examples, basics, and then blink. You'll see that we get a default program. I'll just get rid of all of these comments just to make it a little bit easier to see what's going on. So what this program does is effectively just sets one of the LEDs, in this case one built into the circuit board for output. It sets it to high, which turns it on. It waits for 1 second and then turns it off. So it's pretty straightforward. Now I'm going to make a couple of little changes here. First of all, I'm going to declare constants for my LEDs. So what did we have them in? We had them in 11, 10. So I have a couple of those. 10, 3, and this last one will be the button 2. And so I'll duplicate this, but first I'll set it up so it's easier to edit. So 3 of those, and we need one for the button, which I'll fix up in a minute. So we've got LED 0, LED 1, LED 2, and this is for the button. Now, because we didn't set up a current limiting resistor, we'll say input, but we'll also add pull-up. So that turns on a little pull-up resistor inside the Arduino. I won't go into it why we need that, but it is quite important that you have a resistor or connection on both sides of the button to ground and plus. So in this case we'll use input pull-up, which uses the resistor inside the Arduino, and therefore we don't need one in our circuit. So that's fine. So I'll just load that up as is. First of all I need to change this, and probably need to plug him in first. There's the LED blinking on the board because it's just got the default program on it. So I'll upload this. First we'll check which port it's on. So it's COM14 Arduino, that's correct, and upload. What we should see is one of these LEDs blinking if we're lucky. And there it is, that one's blinking. So what the problem is going to be here is if we want to do 2 things at the same time. So what I'll do first is duplicate this, and we'll upload again. In this case the 2 LEDs should blink in unison, which is fine if that's all we wanted to do. But the problem starts to occur if we wanted to blink them at different rates. So we can't sort of really do that. I mean, you can sort of mess around with putting a sort of different delay in here, maybe make that sort of 500 or something like that, and then another delay here. But it starts to get very messy very quickly, so we won't do that. But what I will do is I'll duplicate this whole thing, because I want to exacerbate the problem. And so now we're blinking LED 0 and LED 1. If I upload that, we should see that they kind of now take turns to blink. And you can kind of see that in the code, that it takes turns, because first we do a blink cycle for LED 0, and then we do a blink cycle for LED 1. Now if you wanted to add something else in there, like for example, if you want to make this third LED follow whether the button is pressed or not, then we can just simply do something like this, and then that will set the third LED based upon how the setting of the button is. So that'll initially be off because we're not pressing the button. Oh, my mistake, it's on. So I need to invert that. But anyway, we'll see what happens. So if I now push the button, then it'll eventually turn off. And if I wait for the cycle to complete and then let go of the button, see, nothing happens until the cycle's completed. Now it's finally registered the button. So that's because it blinks the first cycle, which takes 2 seconds. It blinks the second LED, which takes another 2 seconds. And finally, after 4 seconds, it checks the status of the button and then sets the LED 2. To make it follow the button, I need to invert that. This is the not operator, which inverts the value of this. So I'll just upload that to demonstrate that. Right, and so now the LED's off, as these ones are sort of taking their turns to have a go at blinking. If I push the button down, nothing will happen until this cycle is finished, and then finally it comes on. If I let the button go, it stays on until such time as the cycle is finished, and then it goes off. So we don't want that to happen. Okay, so what's the solution to that? The solution to that is another program, which is also in the examples in digital, and it's called Blink Without Delay. I'll get rid of all of these comments because it's just a little bit easier to read it. So what I'll do is, from the previous program, I'll copy all of this because we'll reuse this, and I'll paste it down here. Now I don't want that. I'll keep this. I don't want that because we're setting the output mode or the LEDs and the buttons here. I'll keep this. I'll call this 0, 0. I'll do interval 0, interval 1 to 700. So the goal will be to set up a blinking so that they blink at different rates. This will be once every second, and this will be every 0.7 of a second. So I need to make a couple of little changes down here as well, because we've changed some of these names. Current millis, that's fine. Current millis greater than previous millis 0. Greater than interval 0. Previous millis 0. And finally 0. This program is a little bit more complicated. We'll look at how it's working shortly, but for now we'll just run it with these particular changes. For the moment we're not using this interval 1, and we're not using LED 1 or 2 or button at the moment, so we'll just leave it like that, and we'll upload that and just should see the first of the LEDs blinking. And so there it is. This one's now blinking at a rate of 1 second. Now I can copy and paste this code. I'll just duplicate it. It's not the best way of doing it or the most optimal way of doing it, but it works. And make changes so LED 1 starts blinking. Now I don't think we had this LED 1 state, so I'll just create that. Now with a bit of luck, the second LED will start blinking, but at a slightly different rate to this one. It's not working. Oh, we have an error. Previous millis 1. Oh, we didn't declare that one. Okay, so now we've got previous millis 1, so we'll upload that. And it looks like that's worked this time. So now you have these two blinking, and as you can see, they're blinking at different rates. To highlight that, we could make one of them blink really quickly, maybe 300. So now you can clearly see, unlike the previous program where this one would have one blink cycle and then this one would blink the other cycle and then would finally check the button, this one is now operating both of them at the same time. Now we can just copy and paste the code from the other one for the button. I'll just again put that at the bottom. So there it is, LED 2 and the button. We have those things declared. And in this case, I'm not going to have all this extra logic because I wanted to check every single time through the loop. And that's kind of a hint as to how this is working. Oh, but in this case, I do actually want to check the button every single time, so I don't need any of this if stuff. So I just load that up, and we'll see what happens. So there they're blinking, and now if I push the button, it comes on instantaneously. If I let it go, it comes off instantaneously. Doesn't matter when I push it or how frequently, it's always working, and that green one is following the presses of the button. Okay, so let's take a look at what's going on here. So the way this works is essentially these if statements. So what the if statement is doing is it's kind of like setting up an appointment. So if you had an appointment to go out somewhere for meet someone for coffee, for example, you wouldn't just sort of set that appointment and then sit there and do nothing until that time arrived. What you would do is you would check the time. If it's the appropriate time to go out for the appointment, then you would go. Otherwise, you'd do something else. So that's what this is doing. So it's saying, is it time to do something with LED 0? So if the answer is yes, it'll do this stuff. If the answer is no, then it'll check this one. And this one is saying, is it time to do something with LED number 1? Again, if the answer is yes, then it'll do this stuff, which blinks the LED, or it'll just continue on down to here. Now this one is a little bit different because it checks the status of the button every single time it goes through the loop. So that's why the loop is now responsive for pushing the button, because if it's not time to blink the first LED, it'll check to see if it's time to blink the second LED, and either way, it will then go down and check the button, and then this will keep going through. And this will execute very quickly, which is why the button is responsive. Now in the case of the other example, what happens is we'll turn the LED on, and then we'll just sit there and do nothing for a full second, and then finally we'll turn it off. So this is the first scenario that normal people don't do. They don't make an appointment to do something in, say, 1 second and then sit there and do nothing. Or maybe if it's 1 second they might, but if it's 1 hour or 2 hours, they wouldn't just sit there and do nothing. They would do something else. In this case, we're sitting here and doing nothing. And then we'll turn the LED off. Then we'll sit there and do nothing. And then we'll turn the second LED on, sit there and do nothing, turn it off, sit there and do nothing, and then finally check the state of the button, which is why it takes 4 seconds to get down here, because we've got these 4 delays, each of which is 1 second. So that's not a good way to do it. If you were getting data from a monitor, like a GPS or a serial monitor or something like that, what this would mean is that you'd effectively miss your input if you don't get it in a timely fashion, because we're waiting for 4 seconds, and we kind of saw that where we've pushed the button but then nothing would happen. So that's not a good way to do it. It's okay for simple things, but it's not a good way generally to write your programs. So this is a much better approach where we just see if something needs to be done. So I don't really like the way this is written, so what I'm going to do is I'm going to modify this one to make it a bit more sort of natural in the way of thinking. So the first thing I'm going to do is I'm going to change this previous millis 1 to next action time. I'll put the 1 in there for consistency, but we don't need to do that. And I'll change the comment, the next time that this LED needs to be updated. So if you like, what I'm changing the concept of this to is, what's our appointment time? What this one is doing is saying it will store the last time the LED was updated, and then what this is doing is saying, well, has an hour or whatever the time gone by? So if we're talking about our appointment in, say, 1 hour, what it's doing is saying, well, we made the appointment 1 hour ago, and it's now whatever time it is. So is that more than 1 hour, and therefore do I need to go? So that's sort of inverted thinking, in my opinion. So I prefer to think, this is when we're going to go and meet someone for coffee or whatever it is. So next action time. And there's nothing wrong with this logic, I just find it's not as intuitive. Okay, so because we've changed the meaning of this, I've forgotten what I called it, next action time, we can simply say if current millis is greater than the next action time. So have we reached, which is the equals part, or are we late, the greater than part? So have we reached, or have we passed the time when we need to go and meet someone for the appointment? So if we've reached the appointment time, then we're going to do this blinking stuff. Now, the other thing that's wrong here is that this again is the logic for, when did we make the appointment as opposed to when the appointment is. So I need to modify this one as well. So the next action time is the current time plus the interval 1. So now we're setting up, unlike this one, is when is the appointment? So if it's 9 o'clock and you agree to meet someone in 1 hour for a coffee, then that means the appointment time is 10 o'clock. So that's what this is saying. So right now it would be 9 o'clock, and then if the current time has exceeded the appointment time of 10 o'clock, then we do this stuff. In the case of the LED, it'll be every 300 milliseconds. So if the current time exceeds the next time to blink the LED, whatever that is, then we say, okay, well, the next time we're going to blink the LED is going to be the current time plus the interval. So we set the time in the future. So hopefully that makes a little bit more sense. I'll just upload it to show that it does the same thing. And so you can see they're still blinking at the same rate, and the button is still responsive because it checks every single time through the loop. Okay, so hopefully all of that made sense, and you can see why it's a good idea to try and structure your code so that rather than sort of doing delays and then doing the next thing, it sort of more sets up appointments and determines when it's time to do something. This is called a state machine. So I mentioned state machines a few times. So what exactly is a state machine? Well, a state machine is a way of representing something. So the main attributes for a state machine are that they all have states, and there are transitions, and a transition is 2 parts. There's a trigger or triggers and rules. So let's just have a look at how the LEDs are being maintained in terms of a state machine. So LEDs have states. They could be on or off, and typically that's represented in a circle. And then there are other attributes in there as well. So there's the time. So in the case of the LED 0, it's the previous time we did something with the LED. In the case of LED 1, that's the next time we are going to do something. And then the transitions can be represented by lines connecting the various states. And then the trigger is this thing here, what actually causes this transition to occur. So this is how it goes from on to off. And it occurs in the case of the blue one when a certain amount of time has gone past from when we last modified it, or when we've reached the next time to do something. And then the off to on is the same. Interestingly, you could have the interval as an attribute in each one of these, and therefore would have different blink rates, so it could be on for longer than it is off, for example. The other one, the third LED or LED 2, which is linked to the button, can also be represented by a state machine. This is probably the simplest one, where basically the LED is equal to whatever the state of the button is, or the opposite of it. And then every single time there is no condition, we just transit to the same state. So this is how we keep checking it. So that one was already a state machine, even in the basic blink, which had the lag. The problem with it was that we just didn't get to execute this transition very often, whereas with this one we execute it very quickly, and that's why we're more responsive, because we're not stuck in any one of these states. Okay, so that's state machines. They can be very useful in designing Arduino programs. Have a look at state machines online. There's certainly lots of examples and documentation about that, but that's what this is, a simple state machine. I think I said that this is probably not the best way of doing it. We've replicated the code. It'll be much better to sort of isolate that. Plus, it's also starting to get a little bit long. And you can see that we had one LED doing its thing, and then by copying and pasting the code, we had a second LED doing its thing, and then by adding more, we had something else doing its thing, in this case the button. So hopefully you can also see that we can do more things at the same time, or appear to do them at the same time, by extending this code out and adding more things to it. So I'll just show you quickly another example. It's a little bit more complicated than the one that we just looked at, but still follows the same concept. So I'd implement some state machines. So here we can see effectively two state machines. One is the this bit, which manages a button. So effectively, I won't go into it now because we'll look at it in a later video, but this one determines when the button is pressed, and when it does, it sets up this, which is the transition for the second state machine. So the second state machine tracks its state by the mode variable. And then there are sub-state machines which use this press event, so I'll look at that in a bit more detail. But the next state machine uses this mode variable, and what happens when the button is pressed is it increments the mode. And then this is the second part, so what happens is it will look at what the mode is and then call one of these functions which displays a different pattern on the series of LEDs. So that's it in action. At the moment it's doing the blink once pattern, that's this first one. If I press the button, then it steps through, so that's the strobe right, strobe left, that's the no action, that's strobe both, so it goes backwards and forwards, and then random, so this one just picks one random one, and then all random just randomly blinks them all. So if I go through and pick the random, and then we can look at that, that's also implements a state machine, so that's up here just a little bit, here it is here. And so this is how it uses the parameter, which is the fact that the button has been pressed. So we set press event to be true when the button is pressed, otherwise it's false. And it passes it to the function, and the way it uses that is to tell it that the state of the blinking machine has changed, and therefore we need to initialize, so that's what that's doing. So if we've pressed the button, we reset the display or clear the display, and then, same as the other blink program, we check to see if it's time to take the next step. And if it is, then it calculates what the next step times. This state machine uses the LED on variable to track its current state, which is the LED that's previously on. So it has to turn that off. Then it calculates at random a new LED, and then it turns that one on. And then, of course, nothing will happen until either the mode changes again or we've exceeded the next step time. So in this case, you can see I've sort of split the logic out into two parts. There's one bit where I've put the logic in here because I only deal with one button. There's no real point in factorizing it out. And whilst it's a little bit complicated, it's not too complicated. But these other ones are a little bit long. So if you could imagine that all this code was in the loop, that would make it unreadable. So what I have done is factorize them out into their own individual functions, which do their own individual pattern. So this program, as I said, is a bit more complicated. This one's 245 lines long. This is the last one we'll look at. This one's 595 lines long, but it also consists of these other files up here as well. And in this case, the machines are implemented inside each of these functions, and these ones are a bit more complicated again. So I've chosen to keep the loop simple and just call these functions. Go and look at that one, 463. This one is the state machine that checks for controller input. So you program this by interacting with it through the terminal serial monitor. So I can issue a command like qdate 14, and what we should see is the bar graph will change. So this is a quarantine clock. You can see this on my Instructables page. This is the check controller input. It sort of manages the state of a serial buffer, and the way it works is that one of the triggers for the transition is if there's data available in the serial device. So if there is, it'll read it. It'll also check to see if it's a special character. If it is a special character like a line terminator, then it'll terminate the string and process the command, and it'll also reset the buffer to basically empty, so it clears it out. Otherwise, if it's not a special character, it just simply stores it in the buffer if there's room for it. So the state change here would be that the buffer pointer would increase if there is space for it, and therefore it captures the character. So as I said, you can see this on my Instructables page. I don't particularly explain the state machine stuff there, but you can have a look at the program in its completeness and see how it works. Okay, so thanks for watching. Hopefully you found that to be helpful. I'd like to hear back from you, so please leave a comment in the comments below. Also, check the like and subscribe and notify buttons so you'll hear about new videos when they get posted. And the best way you can help me is by going over to Patreon and sponsoring me. There's a few different levels there you can choose from. You can also find me on the social media, so Reddit, Instructables, LinkedIn and Twitter and so on. So with that, thanks for watching and see you next time on All About Arduino.